वेलकम बैक टू आवर यूट्यूब चैनल। आज की इस वीडियो में हम बात करेंगे ग्रेविटेशनल रेडशिफ्ट। A second prediction of general relativity concerns the rate of clocks and frequencies of light in a gravitational field as a specific case that illustrates the gravitational redshift is a direct consequence of the equivalence principle. Suppose we consider two identical redshift as a direct consequence of the equations of principle. Suppose we consider two identical light sources A and A dash, the detector B and B dash located in identical spaceships. The spaceship as in the figure 2.21b located fit from the mass at any time t equal to 0 begins to accelerate and simultaneously atoms in the source A dash emits a light pulse of its characteristic frequency during the time t equal to c. The light travel from A dash to B dash. B dash acquires the speed v equal to A G/c, and the detector will be regarding the original locations A dash near the frequency of the upcoming light. Notice that the right side of the equations equal to the gravitational potential. The gravitational potential energy per unit mass Gh between A and B divided by C squared. According to the equations principle, the detector that B and S must be also measure the frequency of the arriving light. Doppler effect. Since the vibrations atoms can produce the light pulse, A can be considered to be clock, and since no cycles of the vibrations are lost, the pulses trip from A to B. The observer and B must conclude the clock and the run slow compared with an identical clock. This shift of clock rates of lower frequencies, hence longer wavelength and a lower gravitational potential in the gravitational redshift. In the more general case of spherical rotating mass change, the gravitational potential between the surface at same distance r from the center at the point and the field is given. Del F over F naught equal to F naught minus F bracket F naught equal to GM over C square होगा। इस तरह आपने ये इक्वेशन 247 और 2 into 48 देख लेनी है। उसके बाद images of distant galaxies are drawn into the arc of the massive cluster of the galaxies Abel's 2018, whose incongruous gravitational field acts as a lens to magnify brightness and discovered the images of Bell's 2218 in about 2 billion CY from Earth. The arc of the January 2000 Hubble Space Telescope's photographs are images of galaxies 10 to 20 billion CY away. Analyzing the frequency of straight line for gravitational effect is especially difficult because several shifts are present. For example, the light is gradually redshifted as it leaves the star and blasted. It can be arise at Earth. The blue shift near Earth, reading the nearby stars and distant galaxies from the part of the general expansion of the universe is typically much larger than the gravitational effect. Together with the thermal frequency propagating in the terrestrial atmosphere, result in the large unconcentrations of measurements. Thus, it is quite remarkable that relative predictions of equations 248 has tested in the relativity small gravitational field of Earth. R.W. Proud and his co-workers first in 1960 1960 and again in 1964 with improved precision measured the shift in the frequency of 14 Kelvin. Gamma rays emitted by falling through the height edge of the 22.5 meter using the Mossberg effect, the extremely sensitive frequency shift measuring techniques developed in 1968 pounds measured agreements with the predicted frictional blue shift within 1%. Using atomic clock carried, the aircraft has described in sessions precision microwave transition carries to 10,000 kilometers from the Earth by space probe. The result of these tests to agree with the relativity predicted frequency shift. The later one part of 14,000. The frequency of equation be shifted to zero and improved in values, which should be corresponding value of R as a star with the mass of Sun. More, the inability of Newtonian gravitational theory to correctly account of the observer rate at which major excess Mercury orbit proceed about the Sun was the orbital problems. Pointing it did it some suitable failure of the theory. Einstein's first paper on general relativity, the real of Mercury orbs, could help explain the advance of Mercury orbits. Take the stage of general relativity is to explain the old Newton's theory. A clear description of the relativity exposition in our page www.whfilms.com. People's Modern Physics. Black holes were first predicted by G.R. Snyder in 1939. According to the general theory of relativity, if the density of an object such as a star is greater enough from the surface not in order to electromagnetic radiation, if it is the first space itself were being drawn inward faster, the light would move outward through a remarkable property of such an object. Nothing that happens inside it can be communication call to the outside world. This occurs when the gravitational potential at the surface of the mass m becomes too large from the frequency of relation entitled to the surface is redshift to zero from the equation. See, the frequency will be zero when the radius of the mass has a circuit value. A precise derivation of the crystal value of the radius Rc equal to mg over c is here. For an object with a mass equals that the other sun to be black hole, its radius would be about 3 km. The large number of black holes has been identified by astronomers in recent years. A large number of black holes have been individual astronomers and interesting historical one is that equation was first derived in the 19th century. French physicist Pierre Laplace using Newton's mechanisms to compare the shape velocity Vc with the planet of mass m before anyone has ever heard Einstein or black hole. The result drives the first year physics course by saying the kinetic energy of the escaping object equals the gravitational potential energy at the surface of the planet Vc equal to 2gm over r. Gravitational waves. Einstein's formulation of general relativity in 1962 explicitly predicted the existence of gravitational radiation. He showed that just accelerated electric change generated times different electromagnetic field in space. Accelerated masses would create the time-dependent gravitational field in space. For example, gravitational waves that propagate from their source and the distortions of the space-times. Experiments are currently underway in several countries. It or directly detect gravitational ranging in Earth. One of the most prominent is the LIGO laser interference gravitational wave observation. A pair of large chemical interactions with the family period characteristics in the Livingstone observation in the Lewis and Fig 2.626. The LIGO detectors are equal arms Michelson interference. The mirrors each 25 cm diameter, 10 cm thick, and isolated from the Earth's motions. Also test masses of the gravitational waves detected. Arrival of the gravitational waves would change the length of each arm of about diameter of an atomic nucleus, result of a higher signal at the photodetectors.